Bienvenidos, Ushamdi, and welcome CMIT 454, Section 6380 and 6382 students for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the CCNA Security version 2.0 course, and this morning's tutorial is going to be a supplement on OSPFv2 authentication. So when we did Packet Tracer Activity 2.6.1.3, we were introduced to OSPFv2 authentication, but there were some statements in there that left us with some additional questions. We were told that MD5, which is how we were doing it in Packet Tracer, wasn't actually the recommended way to do it, because MD5, again, remember, is unsecure. Right? So we should not be using MD5. There's some better ways to do it. And so what I'm going to do here is we're actually going to go ahead and split OSPF version 2, which is for IPv4, and OSPF version 3, which is for IPv6, into two tutorial supplement videos, so that way we could stay on track here. Now we're going to go ahead and do a deep dive here into the different ways to set things up, and we're also going to go ahead and take a look at some Packet Tracer, some Wireshark packet captures, so that we can see some of the proof of what I talked about in terms of when we have no authentication, when we're using plain text authentication where the password is easily seen. So let's go ahead and jump onto the command line here. So I am on real Cisco 2911 routers, and these are running sort of the latest and greatest. And let's start over here with router 12 actually. And it says router 1. I've just changed the name for some other things I'm doing. So I'm going to go from user exec to privilege exec. Now remember, user exec is indicated with that greater than sign. Privilege exec, right, which is similar to being the administrator in a Windows world or the root user in a Linux Unix world, would be that hash or the pound sign. Now once I'm here, I can pretty much do anything I want, but I just want to simply say show version, right? And you can see I'm running 15.7 code, and this is some of the latest and greatest code. Router 13 I think is running 15.6, yeah, 15.6.3. So again, I am running very recent versions of the Cisco iOS code. So we talked about 3 different ways. And let me pull the whiteboard up here real quick, and that way we can track what we're talking about. So we talked about 3 different ways that we could do authentication with OSPF. The first was none, right? And kind of silly that it's considered a type of authentication. It's actually type 0. And I'm not sure if there was a pun intended here or not. So type 0 is no authentication. So 0 authentication. Very easy mnemonic to remember what type 0 means. And then we had the second way to do it, which was plain text, right? Now, again, this is not recommended simply because the password that we use in the hash, or I should say the password used for the hash, is transmitted, and not only is it transmitted, it's transmitted in plain text. Very, very easy to see, and this is type 1 authentication. And then we had our third option, which is cryptographic. So let's say cryptographic. And the cryptographic authentication is considered type 2. Now, we discussed one of the things that causes excuse me, some confusion with learners is they see cryptographic, and let me put an equal sign with a big slash through it here. It does not equal, and again, we're talking about OSPF v2, right? Not OSPF v3. v3 is a totally separate implementation of the security mechanisms, and we'll talk about that. It is not equal to encryption. That's not what cryptographic means here, right? So cryptographic means we're using hashes. Now, the hashes provide us with, excuse me, with authentication that the source that we're dealing with is who they say they are, right? It's protecting the integrity of the OSPF packets. So we're going to start with type 1, and there's also, and I'll put it over here, and let's just say methods over here. So there's a couple ways that we can do this. And we saw the first method in Packet Tracer 2613. And that first method was we do area wide. So I'll say area wide. And then we pair that with an interface configuration, right? So we would say for area wide, area 0 authentication message digest for cryptographic type 2. If we were doing plain text, we would say area 0 authentication and hit enter, right? And again, we have an area wide command in the OSPF global config section, and then we have a little statement under the interface, right, which was IP OSPF message digest key, the key number MD5, and then whatever the password is that we're going to use. And then there was a second way to do it. And again, you can see we've got 3 different types of authentication that we're working with. And again, I'm going to go ahead and I'm going to stick with the standard that this is a type of authentication, even though it's no authentication. And then we've got 2 different methods to do it. And the second way to do it is to do everything under the interface, right? So it's just basically under the interface. And we did not see how to do this, right? We did not see how to do that, and we're going to see how to do that. Now, you can mix and match. So if I have, like we're going to be doing here, router 1, and it's connected to router 2, I can do approach 1 on router 1, and I can do approach 2 on router 2, and this will work. In fact, let me go ahead, and I don't often change colors, but let's put a big green check mark there, right? That will work, right? So we can mix and match approaches. Now, Cisco recommends that you do it on a per interface basis. So from a security perspective, your best bet is to break things down on an interface by interface basis, right? And so this will work, and we're going to see that. So I'm going to router 1 that I'm working on, I'm going to do the area wide in the interface. On router 2, I'm going to do it simply everything under the interface so that we can see both approaches. Now this whiteboard is going to remain here, and we'll be able to come back and reference it. So again, quick review. Type 0, no authentication. Type 1 OSPF authentication is plain text. Type 2 is cryptographic, and that can mean different things like MD5. Right, with OSPFv2, it can mean SHA, and we're going to see how many options we have when we create keychains. And when we talk about OSPFv3, we're actually talking about IPsec. So again, remember, the IPsec is only for OSPFv3, and we'll talk more about that when we get to it. But those all fall under the cryptographic sort of umbrella. All right, let's dive in here and let's start configuring some OSPF and look at some packet capture. So the gig 02 interface on these routers is what's connected. They're connected into a switch actually, and this iMac that I do my tutorials on is also connected with a secondary Ethernet interface into that same switch. And I've created a span session where I'm going to see all of the traffic that goes back and forth between router 1 and router 2 in our scenario. So let's get into global config. I'm going to say router OSPF1. Now, again, we saw this in Packet Tracer 2613. Always a good idea to passive any interfaces that aren't going to be used. I always like to say passive interface default, right? Because that covers me. That means that in order to have the OSPF process running and sending hellos on an interface, I have to say no passive interface. And watch what I mean by this, right? So let's set our router ID. Here's what I also mentioned. The router ID value, right? Since this is router 1, I'm going to set it to something very conspicuous that I can't confuse with an IP address, because that becomes confusing a lot of times for learners who are new to OSPF, trying to determine what is that neighbor ID value, right? What exactly am I looking at? Where is it coming from? And so I'm going to set it, I'm going to hard code it. Again, predictability is a good thing in networking, right? Typically where we get into trouble is where things start to happen that we didn't anticipate or that we didn't think about, right? So predictability is good. We want predictable results. So I'm going to set the router ID. You'll notice I haven't said no passive interface yet, and there's a reason for this. I want to show you what's going to happen here. So now I'm going to go ahead, and you can actually, you don't really need a network statement per se, but let's say we were going to use one. Do show IP interface brief. Now they don't show you this at the CCNA level, but I'm going to show it to you here. Because as you move on in your studies, this is a best practice with pretty much all routing protocols, right? Especially the IGPs. So the way I would want to do my network statement is I can see that this is gig02 and it's 10.1.2.1, right? Because again, it's the subnet between router 1 and router 2, and this is router 1. So typically what you see is 10.1.2.0, and then you see 0.0.0.255 for the wildcard mask. And that's fine. However, the best practice is to literally ensure that you have a statement that is as specific as possible. Again, keeping security at the forefront of your thought process, where you don't want to leave the door open that something could go wrong, whereas maybe somebody plugs something else in. This interface gets repurposed for something, and then another interface comes up with this network, and then you're sending OSPF hellos. So you want to put it specifically, or be as specific as possible, and we're just going to put it in area 0, right? So let's say do show run section, and unfortunately this command that I'm getting ready to run here, do show run, and I'm piping it to section router OSPF. That command is not supported in Packet Tracer, right? But you can see why we have that command, because I don't want to have to sit here and say do show run, right, and then spacebar, 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 right, and I'm spending a lot of time hitting the spacebar, and then I get here and I've got to hit the enter key to go a line at a time. So instead of doing that, that's the command that I would recommend. Do show run, pipe it to section router OSPF. And the reason I have the OSPF at the end is, what if you're running BGP on this router, right? What if you're running RIP and OSPF and EIGRP, right? You can run more than one routing protocol. So this narrows it down, and this it yields exactly what I'm looking for, which is the OSPF router global config section. So now to confirm, I can say do show IP OSPF interface brief, and I don't think this is supported on Packet Tracer either. I think the interface command is, but not the brief option. And this is why you want the brief, right? Compare that to having to wade through this, and maybe you do. There's a chance there's information in here that you may want to see, right? But right now we just want to see which interfaces have we started the OSPF process on, right? Or do we think we've started the OSPF process on? So here it is, gig02. So let me come over to Packet Tracer. Now remember, we have not said no passive interface. So I'm going to start my capture. And remember, when the OSPF process is running, what is it that we should see? Every 10 seconds, what should I see? I should see OSPF hello messages. And remember, that is if and only if the interface is not passive. When the interface is left in the passive state, remember what we said. It's going to advertise that network as part of the OSPF routing domain, right? It's going to advertise it so that other OSPF speakers who are in that OSPF domain see that information, but it's not going to send hello packets. Again, a very, very important security aspect to think about when implementing OSPF. And when we look at plaintext authentication, you're going to see why. You can get, and even with the cryptographic information, there's a lot of information that you can get. Okay, so as we see, there are no hellos. So let's step back over to router 1, and now let's say no passive interface, gig02. So as soon as I do this, and we move back over here, yeah, and it happened so quickly there. So here we go. So now you can see that, let's see, we've got 6647, so it should be 7647, or pretty close. There you go. So every 10 seconds, we have hello packets being sent. Now the packet's already broken out here. Remember, at the front end of all of the OSPF packets, we've got the OSPF header. And it's here where we see we've got no authentication. There's that type 0 or null authentication. And here's my auth data, none. Because again, type 0, which is what that 0 right there represents, tells me that we are not using authentication. So let's go ahead and let's configure router 2 on the other side here. So we'll go to privilege exec into global config router OSPF1. I'm going to say passive interface default. I'm going to set the router ID to 0.0.0.2 for router 2. And we're going to say no passive interface gig 02. And then we're going to say network 10.1, whoops, .1.2.2, which is, I know that's the IP because this is a config, base config I use often, and then we'll make it as specific as possible, and we'll put it in area 0. Now, as soon as I hit enter, we'll step back over here, and we should see, and there it is, right? We've got a lot of those link state packets I talked about, right? Link state update, link state acknowledgement, the hello packets, right? So there they go. And the OSPF database is now synchronizing, and you can see we've gone from loading to full, which means now when I say do show IP OSPF neighbor, right, there is my OSPF neighbor. Now take a look at the neighbor ID value. Isn't it much easier to look at that value and be able to say, oh, that has to be router 1, right? Very, very simple to take a look at that and decipher which neighbor we're talking about. And again, we've got some additional information here, but this just simply shows that the OSPF adjacency has fully formed, right? And that's what this full means. Now that we have things working, and now that we've also seen in the OSPF hello packets, right, that we have null authentication, this basically, so this is part 1 of this sort of 3-part discussion. So type 1 authentication with OSPF is null, and this is exactly what it looks like. So now what we want to do is we want to go ahead, and I'm going to stop this for right now. We want to go ahead now, and we want to set up type 1. So now we're going to transition to part 2 of this tutorial, and we're going to talk about plain text authentication and why you should never use plain text authentication. So we said there's 2 ways to do it. On router 1, I'm going to do, what did I say? What did I commit to here? So we're going to do area wide and then the interface on router 1. And we've seen this, right? This is very simple. We go area wide. I say area 0, authentication. And remember, we're talking about plain text authentication. So in the tutorial, they did the best they could. Again, Packet Tracer is a wonderful tool. It is an absolutely wonderful tool, but remember that Packet Tracer provides us with a scaled down version, basically scaled down to the CCNA level of what we would need to do. So we see, sometimes we don't see everything, but this is the case with Packet Tracer. We see Message Digest because it didn't support that SHA authentication that we're going to be looking at here in a second. So we say Message Digest. So it says use Message Digest authentication or carriage return, which means I can stop right here. Now, stopping here is saying I want to do plain text authentication. And let's see what happens. And again, we'll kick off our Wireshark packet capture, say continue without saving. We'll come back here. I'm going to hit enter. And on router 1, and the source would be 10.1.2.1, we're looking for the hello packets. Well, that one had already come, it looks like, but I'm looking for 10.1.2.1. So here we go. Now, take a look. What is the authentication type? So I said plain text. It's also sometimes referred to as simple. But if I quickly move back over here, do show IP, and hopefully I can get in here, OSPF neighbor before 40 seconds run up. Yeah, look at the dead timer, right? Remember, by default, the dead timer is 4 times the hello interval. So if the hello interval is 10 seconds, the dead timer should never drop below 30. But it is here, and we're going to get a syslog message. And again, very on point, right? That we just talked about syslog. So there's the facility. Is OSPF is sending a notification, right? A notification severity level message that there's been an adjacency change. And it shows that the adjacency change is that we went from fully adjacent to down with our neighbor. And who's the neighbor that we went down with here? We went down with the adjacency on neighbor 0002, right? So we can clearly see, right? Very, very easy to tell who that is. So again, that router ID value, very, very important. So the adjacency is down. Now, remember, this is not everything. So we did it area-wide, but remember, when you have that area-wide command, and again, here's where that do show run section router OSPF comes into play. You can see we say area 0 authentication, but let's remember we need to get under the interface where we're going to say IP OSPF, and what would we say, right? So we've got some choices here. You can see authentication to enable authentication, but remember, we were saying message digest key with MD5, but remember, we're not using message digest here. We're using simple plain text authentication. So if I say authentication, right, you can see null authentication, message digest, or keychain. Well, we're not using any of that. There's an option, and let me back up real quickly. There's an option here. You see authentication key. And what is that? And this is where we would put in, and let me fill that out for you, authentication key. This is where we would come in with the partner command, right? With that second command that's needed for the area-wide configuration. And you can see here the OSPF password is a maximum of 8 characters. So plain text authentication, a maximum of 8 characters can be used. So kind of limits me, but I'm just going to say Cisco 123. So we'll use all 8 characters up. So I say IP OSPF authentication key Cisco 123. So those are the 2 commands. And if I was to say do show run include auth, so we see the 2 commands that we would use. They're right here. IP OSPF authentication key under the interface, and then we would say area 0 authentication under the global OSPF config section. So this is how you do it with plain text authentication. So if we come back over here, if we kick off, or we'll just come down a little bit further here, we should see 10121, and I'll stop our capture. Take a look at what simple authentication does. So this goes to my point that if you have hello messages that are being sent out on a LAN segment where you have users and that user somehow figures out a way to sniff the wire, they are going to get your plain text password. It's right, I mean, take a look at it. We've got it. It's right there. And maybe you're using this password for other things. Maybe it's the same password that you are using for your privilege or for the privilege exec permissions, right? For the enable secret password. And that's where you can run into trouble. So here's where plain text authentication is, it's never a good thing. Never a good thing. And again, we see it in the OSPF v2 header. So it's type 1, Cisco 123 is my password. It's that easy to get that information. So now let's come over to router 13. And we said here, we're going to show you the alternative way to get this configured. So I'm going to go to gig 02 because everything is going to take place now under the interface. So I would say IP OSPF authentication and then IP OSPF authentication key. Again, very straightforward, Cisco 123. And that's it. And what we're going to see here is within the next 10 or so seconds, we should see exactly that, right? That we've now transitioned back to the fully adjacent state because we have the authentication information on both sides of the OSPF adjacency. So if I were to pull this back up and have Wireshark capture some packets, we'll take a look at 10122, and I'll wait for the next one to come up here just to be sure. Okay, there's 10122. And there we go. Simple. So you see all the information here. It's passed in plain text. So this will wrap up part 2 of this deeper dive tutorial with OSPF authentication. So we saw 2 ways to do it. Do show run include authentication. So here's how you do it under the interface, where everything is done under the interface. And here is where you do it, where you have the first command under the area-wide configuration and then the partner command under the interface. So now let's go ahead and let's make some changes here. So we talked about type 0, no authentication, or null authentication. We talked about plain text or simple authentication. Now we're going to talk about cryptographic. So we're on router 1. Let's go back into the router OSPF1 section. Global config section here, where we're going to say area 0 authentication, and now I'm going to say message digest. So let's come over here to Wireshark, and it's still capturing. And so here's 10.121. Now take a look at what we've got, right? That looks much different than the simple do show IP OSPF neighbor. Let's try to sneak this in here before the adjacency goes down. Take a look at the dead timer. And I like to refer to this as the countdown to extinction, right? Where this adjacency, it's only a matter of time because we now have mismatched authentication again. And this is that area 0. Remember, when you put in that area 0 command, it will immediately begin sending OSPF packets with a header that shows that we are using type 2 cryptographic authentication. And you can see we've got a crypt key ID, the data length, sequence number, and then here is this, this jumble of data, right? And we haven't even set the password yet, but it's still sending this cryptographic information, this hash information. Now, this is much better than no authentication, and it's much better than simple plain text authentication for reasons that which should be obvious from looking here at the cryptographic, this data that we're looking at right now. However, MD5 is unsecure, and it is not recommended for use unless you have no other option. It's not recommended for use anymore. So here's what we've got. Now let's go ahead and let's complete our config. And again, what we're doing right now, this is right out of Packet Tracer 2613 because we did use the cryptographic MD5 hash, and we said that message digest key, let me say do show run, section router OSPF. And you'll notice something else. Remember when we had the area 0 authentication? You'll notice I didn't have to say no area 0 authentication and then say area 0 authentication message digest. I simply ran area 0 authentication message digest and it overwrote what was there. So we've got it here, but now I need it under interface gigabit Ethernet 02. And the same thing is true, and you can see here we've got no valid key. Now, what this does not mean, and take a look here, we've actually worked our way up in severity level. So the facility is OSPF. The severity level is 4, warning, and it's saying no valid key. So no valid authentication key is available on interface gig 02 because that's what we're getting ready to do right now. What this does not mean is that you're receiving a bogus key or that we're sending a bogus key, right? It just means no valid authentication. We don't have a send key. We haven't configured it. So this is sort of a local event that we're being notified about. But again, there's that severity level 4. Okay, so we're in interface gig 12. So do show run interface gigabit Ethernet 02. And we are going to say no, and I'm going to pull this out, right? Because we wouldn't say authentication key, and it's giving me some trouble there. We wouldn't say we wouldn't say authentication key with the MD5. We already know that, right? So what we say is, and this is from the packet tracer activity, is IP OSPF message digest key. We'll use a key, and I'm going to use a key number. We'll say 99 to prove that the key number, while it has to match, doesn't have to. You don't have to go in numerical order. You don't have to say key 1 and then key 2 and then key 3. You can pick any key number that you want between 1 and 255. Right? So let's go with 99. And then we're going to say, and let's back up a little bit, what hash can I use? Again, even with the real Cisco iOS, when we're doing the message digest key, it's MD5. That is it. And then here we put what you hear sometimes referred to as the secret. Now remember, with plain text, what was the maximum number of characters we could use? It was 8. With cryptographic authentication, specifically with MD5, the maximum number of characters that we can use is 16. But again, let's just keep this simple. So we'll say Cisco 123, right? And there we go. So now we are properly set up, do show run, include, and again, this isn't a specific section, I'm doing the whole running configuration, include authentication. And you know what? The authentication word is gone under the interface. So let's say message digest is probably a better thing to be looking at, message. Because when I say include, I'm including any line that has this string of text. So here it is for message digest key and then message digest. So here's the area-wide command that we need. and here's the command under, under the interface, right? Again, this is kind of old hat. We saw this in 2613. So now let's go ahead now, and you'll notice we're not getting that message anymore that says no valid key, because we now do have a valid key. If I step over here, we're still capturing. So here's, I want 10121. And you can see that the cryptographic data has changed from what it was. And there is the key ID, right? Remember, we said when we didn't have a key value in there, we were seeing 0. Now we have our key, it's key 99. So let's come over here and let's do the approach that they did not show. So I'm under the interface, but and that's where, I'm sorry, that's where everything is going to be done here. So do show run, and we're going to have to pull some config off. Do show run interface gig 02, and I'm going to say no OSPF authentication, right? Because we're not doing plain text, and I'm going to say no authentication key, because that was the partner command for plain text. So how do we do it all under the interface? Well, we already know the one command, right, which is the OSPF message digest key, and then the key number, and then MD5, and then our secret, right, or our password that we're going to be using, that we're limited to 16 characters. But it's very similar here. You would say OSPF authentication message digest. Now this command's very similar, right? Remember, under the global OSPF thing config section, we say area 0 authentication message digest. Here we're just saying OSPF authentication message digest. So it kind of translates nicely going from that global config area-wide approach to coming under the interface. And then we know this command because this is the same command. Message digest key, and then our key number. You can see we don't have a valid key. So here's what I'm going to do. I'm going to say key 66. And then we're going to see what happens, because we want to make sure that that statement that I made earlier is correct. Cisco 123. So I've got the cryptographic type 2 authentication configured on both sides. On router 1, we did it with the area and the interface command. On router 2, we did both commands under the interface. But now I'm going to kick off a debug here, right? These debugs are fantastic. So we're going to say debug IP OSPF adjacency, right? And what we should see, because router 1 and router 2 right now are trying to establish an adjacency. However, we've got a problem. And what is that problem? And again, the debugs are absolutely beautiful. And a quick note, be very careful if you run these in a production network, depending on what the debug is. Because especially something like a debug IP packet detail, you want to be very careful. In fact, I would recommend an ACL to control the volume of input or output that you see to your screen, because you can lose control of the console, and literally your only option is to power off and power back on the router in question. And if it's a remote router, that might be an issue. So, but again, take a look at the debug here, right? Absolutely beautiful debug. It's giving me the exact scenario or the exact issue that we're dealing with here, right? So OSPF process ID 1, what's the problem? We're receiving a packet from 10121, who is router 1, mismatched authentication key, right? The cryptographic authentication key is 99, and we're sending with key number 66. So again, the key numbers need to match. So let's go ahead and say do you all, and that means do undebug. Whoops, do you all. Or I'm sorry, just you all. We don't need the do because we're not in global config. I'm thinking we're in global config there. So you can see we're going to turn off the debugging, right? Because we don't want those messages to continue, because now we're going to go in, we're going to resolve this issue. So interface gigabit Ethernet 02, and let's see what we have on there right now. All right, so I'm going to say no IP OSPF, or actually no, wait, we want to get rid of this here, sorry. IP OSPF, copy and paste. Message digest key, right? It's the wrong key number, so let's set this up. IP OSPF, message digest key, 99 MD5, Cisco 123. All right, so now what we should see is within the next 10 to 15 seconds here, and I say about 15 seconds because the hellos are going to get sent, And it happens very quickly. Again, these routers are really, really good routers. So we went from loading to full. So if I say do show IP OSPF neighbor, right, take a look at that. We have a full adjacency, right? In the DR BDR election, we're going to leave that conversation for the CCNA routing and switching material. So that's all I'm going to say about that. There's a DR and there's a BDR election, and it's for multi-access segments like Ethernet, and that's why you see that BDR there. So we've got the full state, right? We're fully adjacent. Look at a dead timer, right? Things look good. So with 39, right, it's going to count its way down all the way to 30. And again, in a perfect world, you're never going to see it go below 30 because we will have received, and there you go, 39. We will have received a hello packet from our neighbor, our OSPF neighbor, bringing that adjacency where it's at. I can also say do show IP interface. Sorry about that. I didn't want that. Do show IP OSPF interface. And so here's where, instead of saying interface brief, right? And brief is nice when you're just trying to check and maybe see, like, which interfaces are considered, OSPF interfaces. But if you're interested in seeing authentication information, right, as to whether or not the interface in question has authentication of some kind configured, you would come here and just say do show IP OSPF interface. And you can see the youngest key, which is the key that we're setting, is 99, and cryptographic authentication is enabled. If we go back to the packet capture here, let's go ahead and stop this for right now because we don't need to capture anything. Now, that is MD5 authentication, right? Type 2 cryptographic authentication. And while that is fine and dandy, this should not be used unless you have no other option. And to clarify that statement, when might you not have another option? Yeah, it might be that you're running an iOS that doesn't support a more secure approach and method to securing your OSPF neighbor adjacencies, right? And to authenticating your OSPF neighbor adjacencies. So let's now go ahead and let's do the recommended best practice approach to securing an OSPF adjacency. So what we want to do now is do show run, and actually let's just say interface gig 02. So I'm going to pull this configuration information off. And remember, there's different types of type 2 cryptographic authentication. This is MD5. What I'm about to show you, and we want to get in router OSPF1, do show run. How about do show run section? Let's make sure router OSPF. And so we'll pull this off here. All right, copy and paste. All right, so what I'm about to show you is how to choose a cryptographic algorithm better than MD5. In fact, far, far better than MD5. Far better than MD5. And let's do that. So first, the thing we want to do is we want to create a keychain. All right, so you can see we've got no authentication set up area-wide here. And what we're going to do now is we're going to do the Cisco. This is going to be our recommended best practice here, right? And this is how you want to approach cryptographic authentication, is we want to use keychains. So the first thing that we do, it's very simple, right? We're simply going to create a keychain. I'll just say my keys, right? We pick a key number. As you can see, the numbers are much larger than the numbers that we were dealing with previously, where we had 1 to 255 as our limit. Here, it's, what is that, 2.14 billion keys that we could pick. So we'll keep it simple. We'll just say key 1. Now, just like the password or the secret that we set, we're going to do the same thing here, right? So we set a key, key string. But remember, where we had plain text authentication, the limit was 8 characters. With MD5 cryptographic authentication, the limit was 16 characters. Take a look at the limit here. We have a maximum of 80 characters, right? So kind of crazy long that we could use if we wanted to. But let's make it a little different. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Cisco 1, 2, 3, right? Just something different. Now, here is where we get to the very, very important part of being able to select our cryptographic algorithm. And you can see that MD5 is still here. Again, from a legacy perspective, maybe the router on the other side doesn't support keychains. So if I was to come over here to router 8, right, and this router, it's running 15.1 code, yeah, 15.1.4, right? If I was to say, go into global config and say keychain, and we'll just call it ABC, and then say key 1, and then do a question mark, is there an option for cryptographic authentication? No, there's not. In fact, if I was to come to a router that was running 15.3 code, and we'll get into privilege exec here, and you can see 15.3 code, right? If I was to say, go into global config and say keychain ABC, and then key 1 question mark, it's not even here. So the cryptographic algorithm, being able to select a more secure, a more robust hashing algorithm didn't exist in Cisco iOS until 15.4 code. And that is probably within the last couple of years. So again, this is something that's not terribly new. So to answer the question as to why does it still show MD5 here, it's possible that you want to use keychains on this side, right? But that the other side doesn't support those other cryptographic algorithms, right? So we want to be able to provide legacy support. So, but what I'm going to say here is cryptographic algorithm and larger in a numeric sense, right? 512 is better than 384, is better than 256, is certainly better than HMAC SHA-1. In fact, let me pull this document up here. If you were to Google Cisco Next Gen Encryption, and I think I've included this in the course area in the Leo system, take a look here. And this is a beautiful, phenomenal chart that shows all of the different algorithms. So MD5, it's used for integrity, right? We've been talking about this. CIA, remember that, right? The confidentiality, the integrity, right? We're making sure that the neighbors who they say they are, what is the status? Avoid, right? We should be avoiding this. SHA-1 is legacy. Here is what we should be using at a minimum, right? At a minimum, we should be using SHA-256. And so this goes on, right? You can see there's some other information here toward the bottom, but this gives you a great idea as to which ones you should be using. Take a look. AES CBC is acceptable. And we'll see that as we move through the course and talk about some other types of IPsec features that we may want to enable. And again, so look at the Diffie-Hellman key exchanges, right? So we should be using group 15 sort of at the low end. And again, group 24 is at the high end, and that's probably the recommended group, again, if both sides support it. So we're going to say HMAC SHA 512, right? Cryptographic algorithm HMAC SHA 512, and we already have our key string. So let's say do show run, and we'll begin at chain. So we're going to start in the config because we want to see what does our config look like. Now, I can just do this. I can copy it. I can come over here and paste it in to make sure that we get everything in here. Now, there's a couple of quick things that we need to talk about. So I'm going to come back over here to router 1. Now, we're not done, right? Because we have to go under the interface, Gigabit Ethernet 02, and I need to say IP OSPF authentication keychain. And if I back up a little bit, remember, we've seen this authentication before. And this is where we would say message digest. But here, we want to say keychain and then the name of the keychain, which, correct me if I'm wrong, it was my keys, correct? There it is, my keys. All right. So I say IP OSPF authentication keychain my keys. We're going to see a syslog message here. We should shortly, I believe, indicating, and maybe it's on the other side. I would think we would see a syslog message saying that we're sending a key, but we're not receiving a key. But that is it from a configuration perspective. Again, we go ahead and we create our keychain, which you see here. We select the most robust SHA algorithm that we can, right? And we put in a key, a string, a secret that could be up to 80 characters. And okay, we see the adjacency go down, right? Because we've got the authentication set up. Now, a couple of quick notes. Take a look here. key string 7. Now, again, we're in the Cisco, I've got service password encryption is enabled on this router. And that is why it's protecting it with the simple Cisco Type 7 cipher, which I can literally cut and paste this, right? And let's see if that works. And here's what I'm talking about when I say that you can literally come out here. We'll go to Google and we'll say Cisco. Cisco password decrypt. So we can come right here and IFM Cisco password checker. Let's paste it in, say crack it, and there it is. It is that simple. And I apologize, that's awfully tiny. There we go, a little better. I mean, so take a look at that. Super, super easy. And that took me like 15 seconds to make that happen. So, but again, let's be clear. Cisco has been very upfront that this convention of using type 7 in the running config is not to stop Guccifer, right, or Anonymous from figuring out what this password is. That's not what this is for. This is for the shoulder surfer. So that maybe that junior network admin that thinks he's the senior network admin, and just if he could just figure out what your enable secret password is, he would be off and on his way. Or if he could figure out what the key string is here for OSPF, that he could practice in the production environment by setting up keychains on routers, right? You wouldn't want that to happen. And so that is going to be a lot easier, or I'm sorry, a lot more difficult to remember or memorize by taking a look at it than simply seeing it in plain text. So again, it's a type 7. Now, even with this, all you would have to do, if let's say you had an admin that was there, he didn't document anything, and then the guy takes off, right? This has happened to me before. Guy didn't document anything. I come in to help the customer. They've got no documentation, and they're like, hey, we don't know what passwords he was using for the key string, right? Well, it's very simple. Show keychain, or I'm sorry, passwords for the keychain. So show keychain, my keys, and watch this. There it is, right there. Now, you may be saying to yourself, well, wait a second. You just told us that this is the most secure way to lock down and provide integrity for this OSPF and authentication here for this OSPFv2 adjacency, and it is. Because think about the prerequisite for someone to get that information. What mode am I in right now? Yeah, I'm in privilege exec mode. Again, remember, Unix, Linux, this would be like root. You can do anything you want. Windows, it would be like the administrator. Again, you can run off and do anything you want. So the prerequisite would be that someone would have to have your privilege exec password and be able to get into privilege exec, at which point, if I'm being honest, the least of your concerns is that they figure out what the key string is that you're using in your keychain. Because at this point, I can do anything. Now, let me say disable, right? And I'm going to go back to user exec. Can I say show keychain, show keychain my keys? No, because in user exec mode, I don't have the privilege to run that command. I have to be in privilege exec to be able to say show keychain my keys. So again, very important, right? Very important. Remember, to get this information with this command, the individual would already have to have your enable secret password, right, to get into privilege exec. If they've got that, again, this is the least of your concerns, that they're going to be able to see this information. They can do anything they want at this point, right? All right, so let's get on to router 2. Let's wrap this up here. So we're down, right? Do show IP OSPF neighbor. We can see that we're down, right? There's no neighbor adjacency here, and let's get out of the keychain setup here real quick. And that's right, we did the cut and the paste, and we want to go under interface, gigabit Ethernet 02, and we want to say IP OSPF authentication, keychain, and then my keys. And what we should see now is in about 10 seconds, and man, pretty quick, right? We've got a loading to full, do show IP OSPF neighbor, right? So we can see that the adjacency is up, do show IP OSPF interfaces, do show IP OSPF interfaces. What does it show down here? Take a look at that, right? Cryptographic authentication is enabled, and this is the Cisco recommended best practice. This is what you should be doing to secure your OSPF neighbor adjacencies. And the final thing we're going to look at, let's go ahead and say, let's capture some packets, and we'll wait for the next set to come in just to be sure here. And there we go. So you can see the hello packets are still going. If there were updates, all of the OSPF packets are now going to have what? Again, you can see even though it's HMAC SHA 512, even if it was 256, 384, 120, and 1, it would still say the authentication type is cryptographic type 2. That's the key that we chose. There's the length of the data. Here's the sequence, and there is, and you can see how, I mean, look at this dot, 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 and here are the hexadecimal representation down here. But again, the key takeaway is look at how much longer and more secure the cryptographic data is. And again, nothing else is encrypted here, right? The hello packet, is that all encrypted? No. So remember, all cryptographic authentication means with OSPFv2, which is OSPF for IPv4, is that it sends in the OSPFv2 header an authentication, series of authentication information identifying the type of authentication, the key if we're using type 2 cryptographic, our sequence number, and then the data. And all of that is what's being used to secure our OSPF adjacencies. And so again, there's 3 types of OSPFv2 authentication that are how we classify the authentication. Type 0 is none or null. Type 1 is plain text or simple. Type 2 is cryptographic. And under type 2, we've got different ways that we can achieve it. We can achieve it with MD5 and we can achieve it with SHA. But remember, type 2 cryptographic authentication with OSPFv2 is not encrypting the OSPFv2 packets. It is not encrypting the traffic on those interfaces, right? It is simply inserting a hash into the OSPFv2 header to provide that authentication. And the methods to achieve setting up the authentication. We can do area-wide in the interface, and we saw that in our previous packet tracer activities and on router 1 here. And you can do everything under the interface, which is what we were doing on router 2. All right, well, hopefully you guys have enjoyed this deep dive. For those of you that were interested in getting a much better understanding, and I'm sorry, I need to move out of here to get back to here, have a much better understanding of just how you can approach authentication with your OSPFv2 adjacencies and what that little note meant when we saw it saying, well, this version of Packet Tracer only supports MD5 authentication between the OSPFv2 speaking routers. Again, best practice, set the keychain up and set up the cryptographic authentication and set it up with the highest, in our case it was HMAC SHA 512, with the highest numeric value that you can. And that is how you want to secure your OSPFv2 neighbor adjacencies. All right, guys, thanks so much for watching. Again, hope you enjoyed the video, and I will talk with you soon.